Hello, everyone, and welcome back to the podcast. I'm Jimena Ibagon, and today I'm excited to share with you some insights from our latest research on the effects of using soybean meal, canola meal, and corn distilled dry grains with solubles, also known as DDGS, on net energy, greenhouse gas emissions, and nitrogen balance in group house peaks. Let's start with a bit of background. Understanding global greenhouse gas emission is more important than ever, especially as concerns rise about the carbon footprint of the products that we consume and produce. If you take a look at global greenhouse gas emissions, energy tops the list, followed by industry, but agriculture, forestry, and land use together make up about 22% of the total greenhouse gas emissions. Within that, crop and feed production contributes around 45%, and methane from digestion, mostly from cattle and dairy industries, accounts for about 39%. The manure storage contributes with 10%, while the processing and the transportation of the livestock products contributes with 6%. It is important to note that while methane emissions are higher in ruminants, swine contribute less, but still remain under scrutiny due to the nitrogen excretion in manure and gaseous emissions like carbon dioxide and methane from the pigs. At the same time, energy is the most expensive component in swine diets, and since feed production contributes significantly to emissions, determining the energy concentration in each feed ingredient is critical, not just for cost, but also for reducing overfeeding and environmental impact. So how do we address both cost and sustainability? By formulating balanced diets with the right protein and amino acid levels. This can help to reduce nitrogen waste, and since gas emissions are tied to feed composition, it is possible that high fiber ingredients can affect the gas exchange of the pigs, which affects the net energy of the diet, and therefore it is possible that by feeding low fiber ingredients in the diets, we may reduce the greenhouse gas emission. This brings us to the motivation behind our work. With the growth of the ethanol and plant-based oil industries, ingredients like canola meal and DDGS are more available as an alternative protein sources after soybean meal. However, there is still a knowledge gap in how these protein sources compare when it comes to net energy, greenhouse gas emissions, and nitrogen excretion. So the objective of our experiment was to test the null hypothesis that there are no differences in net energy, greenhouse gas emissions, or nitrogen balance when pigs are fed corn-based diets with these three different protein sources. Now let's move into the materials and methods, and I will start with the diets. We formulate three diets. A corn soybean meal diet with 77% corn, 20% soybean meal plus synthetic lysine and threonine. A corn canola meal diet with 71 corn, 26 canola meal plus lysine, methionine, tryptophan. And a corn DDGS diet with 68% of corn, 31% of DDGS, plus synthetic lysine, methionine, threonine, and tryptophan. All diets were formulated to have similar crude protein content and indispensable amino acid requirements based on the NRC guidelines for pigs between 40 and 80 kilograms. The experiment took place in the swine calorimeter unit at the University of Illinois, which allow us to use indirect calorimetry to measure net energy in group house pigs. This facility has 6 chambers, and each chamber has 2 sections. The upper section is where the pigs are housed, as you can see in the image if you are following along, and the bottom section is used for total but separate collection of feces and urine. This design allows us to measure not only gas exchange, but also accurately quantify the nitrogen excretion from both feces and urine in group house pigs. We use the chamber as the experimental unit with 24 growing pigs, initially average body weight of 47 kilograms, reaching out about 85 kilograms at the end. Pigs were housed 4 per chamber, and the experiment followed a 3x3 repeated Latin square design using 6 chambers across the 3 periods. Each period consisted of 7 days of diet adaptation followed by 6 days of data collection, during which we collect total but separate feces and urine. We measure oxygen consumption and production of methane and carbon dioxide for the calculation of total heat production. After those 6 days, pigs were deprived of feed for 36 hours, and during the final 12 hours after 24 hours of fasting, we collected urine, and again we measure oxygen consumption and production of methane and carbon dioxide. This allows us to calculate fasting heat production for the determination of the net energy. We analyze all data using the mixed procedure of SAS with diet as the fixed effect and period and chamber as random effects. We use pairwise comparisons to separate the means with the adjustment of Tukey. Alright, now let's move on to the results. But first, I would like to share my slides. You can see in dark blue the diets containing soybean meal, in light blue the diets containing canola meal, and in orange the diet containing DDGS. When we look at the feed intake corrected for the ORDs, a tendency of greater consumption of pigs fed the soybean meal and DDGS diet than those on the canola meal diet was observed. Interestingly, when we talk about the ORDs, pigs on the DDGS diet also had a higher feed wastage compared with pigs fed the canola or the soybean meal diets. As for apparent total tract digestibility of dry matter, pigs fed the soybean meal had the highest digestibility of dry matter, which makes sense given its lower fiber content compared to the fiber in the canola meal and the DDGS. Now let's talk about net energy. In our results, we observed that pigs fed the DDGS diet had a greater net energy in their diets compared with those fed the canola meal diet. However, there were not significant differences in the net energy between pigs fed the soybean meal diet and those fed either the DDGS or the canola meal diet. It is important to highlight that in this experiment we use a high oil DDGS, and we also carefully balanced the diet with synthetic amino acids. These factors likely contributed to the higher net energy values observed in the DDGS-based diet. So while DDGS is typically higher in fiber, the added oil and optimized amino acid profile may have helped improve its energy contribution in this case. Now let's move on to the greenhouse gas emission measured in liters per pig per day. We'll start with oxygen consumption, and while the overall model was statistically significant, the adjusted p-values from the pairwise comparison were not significant, meaning we didn't detect differences among the diets in that specific measurement. When we look at the carbon dioxide production, however, we observe a tendency for greater carbon dioxide emissions in pigs fed the soybean meal diet compared with those fed the canola meal or the DDGS diet. As for methane production, the values were very close to zero across all treatments, and no differences were observed among the diet. This aligns with what we mentioned earlier, that methane contributions from pigs are significantly lower than those from ruminants, like cattle or dairy cows. Now let's look at emissions per kilogram of weight gain, which give us a production-based perspective. Again, for oxygen consumption, the model was significant, but the adjusted comparisons were not, so difference between diets were not observed. For carbon dioxide, we saw a tendency for higher carbon dioxide production per kilogram of gain in pigs fed the canola meal diet compared with those fed either soybean meal or DDGS. And once again, methane production per kilogram of gain was close to zero and not different among diets, supporting again the idea that methane emissions from pigs are minimal compared to those from ruminant species. Let's now talk about the nitrogen balance. We will begin with the nitrogen intake, and in this case, we observed no differences among the diets, which was expected because all three diets were formulated to have the same crude protein content. So the amount of nitrogen entering the system was consistent across all treatments. Now, moving on total nitrogen excretion, which includes nitrogen loss through both urine and feces, we found that pigs fed the DDGS diet had a greater nitrogen excretion in feces compared with pigs fed the canola meal or the soybean meal diets. On the other hand, when we look at urinary nitrogen, pigs fed the soybean meal diet excreted more nitrogen in urine than those fed the other two diets. But when we consider total nitrogen excretion, urine plus feces, there were not significant differences among all three diets. Now let's move on to nitrogen retention expressed in grams per day, and in this case we did not observe differences among pigs fed any of the three diets. Similarly, when nitrogen retention was expressed as percentage of nitrogen intake, the results were also not different between diets. However, it is important to highlight that nitrogen retention exceeds 60% of the nitrogen intake in all diets. This is consistent with recent research showing that modern pig genotypes have higher nitrogen retention capacity than older genetics. So, these findings align well with what's currently reported in the literature. Lastly, we look look at the biological value of protein, which reflects how efficiently the pigs use the nitrogen they consume. Here, pigs fed the DDGS diet had a greater biological value compared with those fed the soybean meal diet. However, there were no significant difference between pigs fed canola meal and those fed either DDGS or soybean meal. So what's the takeaway? Soybean meal and DDGS had greater net energy values than canola meal in corn-based diets, and greenhouse gas emissions were lower when pigs were fed soybean meal or DDGS. This means we reject our initial null hypothesis that there are no differences in net energy, greenhouse gas emissions, and nitrogen balance based on the protein source in pig diets. With that, I would like to give a big thank you to the United Soybean Board for funding this project and to everyone at the State Monogastric Nutrition Laboratory for their help and support. If you'd like to know more about our research, please visit nutrition.ansi.illinois.edu and make sure you stay tuned for more episodes focused on swine nutrition. Thanks for listening and see you next time.